Hi. Okay, so I've got lots of little updates today. I've done better this time at being more robust in terms of my science. I'm not changing as many things at one time. First of all, though, I've got an update to my battery tester. I 3D printed a little box. Improved the box. You can see now it has the the corners, and I have a place to screw in the top instead of just laying it in there. So it's a nice little project box. It's a good first design for someone just getting into 3D printing. This is what the 3D box looks like now, the battery tester box. I plan on making enough for each child to use one independently, but it's just a nice little tester box. I'm happy with how it is. This is 12 volts coming in from the wall. This is the step-down converter. It's adjustable. Right now it's set to about 2 volts. And then this just monitors the battery. The top is the battery voltage. The bottom is the amperage between the battery and the load. This switch changes between charge and discharge, and the middle has a middle neutral position. So if I charge, you can see that the battery, the connectors that would go to the battery, actually these two, jump up because then it's that. But then when it goes discharge, the voltage would be supplied by the battery. And then I just use these speaker connectors, standard speaker connectors, as the place to connect the wires, because I can plug into them, I can put a wire around them, I can put an alligator clamp into them, lots of options. And so I'm pretty pleased. I'm going to build, it's held on by the 4 screws into the 4 corners of the other box. Pretty pleased with it. I'm going to keep it and probably build one for each of the students, or have them build it actually. I'll print the pieces and then have them build it as the first week. So that's the battery tester. It's doing good and I look forward to using it. Now, what I've done is I wanted to get an idea of how long I needed to cook the graphite, the mixture. How long to get a good carbonizing on the sugar. So for all of these things, I'm using this same mix. I'm using 5 grams of sugar, 5 grams of salt, a gram of urea, and a gram of flake graphite. So I have the same thing for all of these. The urea is coarser, and the flake graphite is very fine. I put all these together. I put them into a coffee grinder, ground them up into a nice fine gray powder, and then I proceeded to microwave them. First, what I did is I wanted to give you an example of what the microwave was looking like, and I wanted to see it myself. I tried to video it. I'll put that right after this, but it didn't turn out as well as I want. Probably need a darkened room, and I have a little problem with that because it's smoking, and so I can't really keep it inside, so I've got to figure out how to do this. But what I did is I just put the graphite straight into a open dish like this with a tile on top. So very little oxygen control, but a tiny little bit. And then I turned it on, and you can see it sparking in person. You can see it sparking really nice. You can see the powder in the video. That right after this you'll see it's a little hard. After a few minutes it was smoking and sparking, and the glass that I used pretty much exploded into the microwave. It pretty much went everywhere within the contained microwave, of course. Didn't hurt the microwave, didn't hurt anything, but it really did explode. Interestingly, what I got out of that was this. Whoops. What I got out of that is this, of extremely light piece of carbon. And it is interesting because I really didn't take much in the way of precautions and didn't worry much about the oxygen. But boy, this really carbonized nicely. I've got a really fine thing here. I hope I have enough to make a battery. I think this is just barely going to be enough. I'm going to try to make a battery with that and see what happens. So then I started going, okay, I'm going to make my carbons. And I started off, when you kick the carbon off, when you start it cooking in the microwave, the first thing you get is nothing. And then after about 30 seconds or so, you get smoke. And the microwave smokes a good bit. Don't use a microwave you want to use for cooking. Don't do it inside or without a flame hood, or a fume hood, I mean. You need to be, you don't want this stuff. It's probably just cooked sugar, burning sugar, if you will. So it's not like it's a bad noxious gas, but you don't want to have that breathing around. So I started off. I had 3 of these tiles below each of the cups, and then I had a silicon pad to kind of make a little bit of a seal, and then I put the smooth part of a tile on top of it. So I got a fairly decent seal through the cup. Not perfect, but a pretty decent one. And I had a pretty decent amount of insulation down below it. Inside, okay, this one, these first 2 I cooked until they started smoking. So I stopped it as soon as I saw smoking, which was basically at 27 seconds. I have 2 that I was cooking at the same time. So this is 27 seconds, and you can see that I got a puff-up type of graphite or carbon. Now, one thing I did is when it cooled just a little bit, I touched it, it felt almost sticky. So I haven't actually tried these graphites. Well, there we go. It's pretty loose, pretty powdery, extremely light. It may be that all these carbons work very similarly, and that's what that's why I'm testing this. I want to see. I'm hoping to make a couple of batteries for each of these carbons, but you can see it's a nice little carbon. Come on, focus, please. Oh, come on, focus. Can you get that close? No, you can't get that close. Anyway, it's a nice little carbon, and I'm going to grind it up anyway. It has a little, it is sticking a little bit there. So nice little carbons. This is 27 seconds. Nice and quick. I love the fact that it was quick, because when I'm doing a whole classroom of batteries, if something is that quick, that'd be awesome. So that was when I stopped it right as it started smoking. This next batch, I stopped right when it stopped smoking. So this ended up stopping at about 3 minutes and 43 seconds. Same thing, 3 below, 1 on top. Notice that none of these are cracked or broken, which is good because that's something I've been having a problem with. It looks like the carbon is bigger. The expansion is bigger in this than it was in the other, almost twice the volume. That's probably a really good thing. There we go. Oh, wow. That is light, and it crumbles so easily. It's still a beautiful looking carbon, but wow, that crumbled beautifully and easily. Okay, this is looking great. I'm liking this a lot. It has you can see the specks in it where it still has the salt. That's fine. Then the next step is to wash this out. My final thing was to test, because I'm trying for robustness now. I'm trying to do this right. My final thing is I cooked it for the time that I had success on before, and that is the full 13 minutes. Now, here is the first one for 13 minutes, and I see that you probably can't see it on this, but I got a nice crack on the cup. It looks about as puffed up as the 3 minutes and 43 seconds, so about as puffed up as when it stopped smoking, and here we go. Okay, it feels good. It's the same type of ultralight feeling carbon as the other. It feels good and looks good. I like this. I'm liking this a lot. Me likey. Okay. So that's pretty cool. Now, this one broke the cup, and on the other one, not only did it break the cup, it broke the tile underneath, and I ended up with a broken cup. But again, I have a nice hunk of carbon inside there. Nice, very, very light carbon inside there. So I'm going to see what happens when I build that into a battery. So my next plan is to take all of these carbons one at a time, and I'm going to put them in through a grinder, make them a powder again. Then I'll put them into a coffee machine, just a standard coffee pot. One of these guys. A standard coffee pot with a filter on top, and it drips through. And so I'll drip 12 cups of hot distilled water through, rinse it all out really good, and dry that, and make that into an ink using, right now I'm going to continue to use the same Type Bond 3 that I've been using. I'm going to use my newer battery construction technique because I think that's better. So I'm going to have a lot of batteries to test, but I've got the tester and I think it's going to work out well. I've got 1, 2, 3, 4, 5, I may have 6, 7 batteries. I have 7 batteries to test. I'll have 2 for each time. I like that because it gives me some idea if there's a variable, how variable each time is. So in my next video, what I'm going to do is show you the results of the batteries as I test them. Thank you very much.